Hey everybody, welcome to week 3 of PS 398. By the way, before I get too far started, my voice is going to sound pretty weak. I'm sorry about that. You're going to see plenty of this giant cappuccino mug full of honey lemon water. On a personal note, I just spent the last 4 hours recording this lecture, only to find out that my battery died halfway through and the whole video was lost. I'm going to work really hard to keep the energy levels high. I can do this a lot. Look at this. Put on some dance music. This is me dancing. I got energy. I got a lot of energy, all right? But my voice doesn't. So I've turned the gain way up on my mic, and I hope that that's enough for this to be somewhat acceptable for you. Personal note done. The topic of today's lecture is the problem of preference aggregation. What does that mean? Well, in the previous lecture, we spent quite a bit of time exploring 3 different flavors of the same fable, the fable of the rational actor. So we talked for a while about preferences and what a rational preference is. And, you know, even though we talked about 3 different versions, probably the thing that's going to be the most useful for you to think about today is the version of the fable, the first version, the fable of the rational preference relation. And the idea there was that if you give me a set of alternatives and ask me my personal comparison between each pair of alternatives, then my preferences over those pairs have to satisfy certain properties. And those properties were reflexiveness, completeness, and transitivity. Where the idea was reflexive meant that something was as good as itself. Completeness meant that every pair of alternatives was in some sense comparable. And then transitivity meant that you could make consistent inferences and that all of the goodness or badness of alternatives kind of went down the same hill. But that was a fable about one decision maker in isolation thinking about one set of alternatives. And it wouldn't be very interesting for us to talk about one decision maker for very long because we're talking about international relations. Most international processes involve multiple people, or multiple countries, or multiple firms, or multiple organizations, or multiple whatevers, right? So how do we take what we just learned about how individual actors behave in a vacuum, and how do we turn that into what happens in interdependent settings? And that's what game theory is there for. But I want to pause. And the reason I want to pause is that international relations has a unique methodological problem that is easiest to see through the lens of a really important normative theorem. And what does that mean? Well, there's a levels of analysis issue in international relations, right? So we're going back to Ken Waltz, who got mentioned last week, and he has a famous book entitled Man, the State, and War. And it's a book about international relations, but it's also a book about method of international relations. And you sometimes hear about the 3 images of IR. There's an individual level, there's a state level, and then there's the international system. And if you want to study the first level, you might look at individual level preferences, the individual level. You might look at individual level preferences over alternatives, or you might look at the cognitive processes within a leader. You might think, hey, how does that leader making choices? So highly individualistic, get inside a brain. Figure out how individuals are making choices. His second level is the state, and there's a lot of good IR scholarship that takes the state as its unit of analysis, where the idea there is that there is some way of taking all the individuals in a given polity and aggregating them into something that is, in some sense, a societal preference ordering, right? So if you have a preference and I have a preference and all the students in the class have a preference over whether or not the exam should be take home or in class, right? Then we can come up with a policy. Hopefully our group policy, the class policy, reflects, some amalgamation of all those preferences. But there's a lot of interesting wrinkles to that aggregation process where we go into the fable with a bunch of individuals with their own preferences over the alternatives, and we have to convert those into some societal preference. I just said we have to turn one thing into another thing, which should have you thinking about blobs and dots and arrows, and today's class is going to be quite a bit about blobs and dots and arrows of a particular form. It turns out that the most memorable thing that I can tell you about this problem is also one of the most important things ever developed in the formal social sciences. The problem of preference aggregation transcends the methodological issues of international relations, where it's like, oh, can I give a country a utility function? There's more to it than that. I hope that after today's lecture, you just think differently in general about citizens' place in society. Or at the very least, it gives you reason to want to reflect. Because I don't think that there's a right way to look at this necessarily. I don't think that there's a best way to look at this necessarily, but the truism that I'm going to show you today, when a lot of people see it the first time, it's a moment that they remember. And I hope that that works for you as well. Even in this second iteration of taping, I'm ambitious about the goals for today's lecture. So my hope actually is to give you a complete picture of the very rudiments of social choice theory. So we're only going to spend 1 week on this. This is not game theory. I'm not teaching this lecture in my game theory class. I think this is especially useful to think about in terms of IR. I've bitten off a little bit more than I can chew. I learned that during the tapes that are now destroyed because the battery ran out. And you would think, hey, maybe he'll change his plan. Not so. If you haven't noticed by now, I'm nothing if not persistent. I hope that today's lecture isn't too much. The problem set won't require everything, right? So let me just say in advance, your problem set this week will not require for you to understand everything in today's lecture, which is great because chances are good that you won't get it the first time. I didn't. Nobody does. Okay? However, I want you to remember this, and there might come some time where you're really bored, and you might say to yourself, hey, I might try to think about that a little bit harder. And here I will be, waiting for you, with a tired voice. So in the A block, I want to frame the problem. I want to frame the problem of preference aggregation. I want you to get a sense about what it is that we're talking about. How do we take a bunch of individual level preferences and turn them into a societal preference? What are the functions? What are the sets? All right, and that helps. Just having a sense about what the picture looks like really helps. In the B block, we'll talk about different criteria that one might impose on a method of aggregating preferences, right? So there are many ways to choose from a set of alternatives. If we're a bunch of people trying to pick a movie, how many different procedures could we choose? Many. We're not going to be able to study them all, right? Instead, we're going to think about axioms that one might impose upon these preference aggregation procedures that are in a sense good. We want to choose a good way of aggregating preferences. What does good mean? Well, we'll talk about that. And a lot of the things that I'm going to say will be things that a democratic theorist would have a pretty good giggle about, and understandably so. If you're interested in the things that I show you, I hope that you'll consider taking a class in democratic theory. We have some wonderful faculty that will be able to help you to learn much more about how these things all work together. I just hope that I can whet your appetite a little bit. And then, rather quixotically, in the C block of today's lecture, even though I just tried it once and wasn't quite happy, we're going to try it again. We will prove Arrow's theorem. Right now, Lucy, the grader, is probably saying to herself, oh, what is he doing? It's a fine question, Lucy. I don't know. But we're going to try. So, our goal for today is to go from nothing to one of the single most important results of the 20th century in the social sciences. Let's get started. Here in the A block, I just want us to get a sense about what it is that we're talking about. And you're like, that sounds great because that introduction didn't make any sense. Point taken. I'm having a conversation with a fake you that is just me. I mean, fake you is very mean. So suppose that you, my dog Chewy, and I decide to start the Greater Champaign Urbana Alfred Hitchcock Appreciation Society. That's a pretty serious thing, right? So the three of us are the charter members. We are the founders of the Greater Champaign Urbana Alfred Hitchcock Society, Appreciation Society, all right? And at our first meeting, our goal is to say, hey, what's the best Alfred Hitchcock movie? So suppose that the three of us all have rational preferences over the set of Alfred Hitchcock movies. Okay? We have preferences over Hitchcock movies that are reflexive, complete, and transitive. One of the big things in today's lecture is that we're going to begin from the Homeric assumption that everybody in society has a rational preference relation over the set of alternatives. And you're like, why would you do that? People aren't rational. Some people are, some people aren't. That's true. And so what I would say is, wouldn't it be interesting if bad things happened even though everybody in society will live up to the rationality criteria? So let's just suppose for now that everybody's rational. Every individual in society, we have a bunch of citizens, and they have rational preferences over a set of outcomes. Suppose that all of us agree that the best three Alfred Hitchcock movies are Vertigo, Psycho, and North by Northwest. But the thing is, we can't agree on what the best among those is. Suppose that you have the following preferences. So you, an Alfred Hitchcock fan, and a charter member of the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society. That's not an easy one to put an acronym for, is it? So you, a charter member, your favorite Alfred Hitchcock movie in this scenario is Psycho. Your second favorite is Vertigo. And your third favorite is North by Northwest. This tabular way is my way of saying that you have a strict preference over Psycho over Vertigo, and a strict preference Vertigo over North by Northwest. I'm assuming that you're transitive, I'm assuming that you're reflexive. This is just an easy way for us to say, hey, there's a strict preference there. If I put two alternatives on the same line, then that means indifference. And transitivity means that this is all very well behaved. So those are your preferences over these top three Alfred Hitchcock movies. Chewy, on the other hand, his favorite is Vertigo. He loves the colors. His second favorite is North by Northwest. And his least favorite is Psycho because he can't stand black and white movies. And me, well, for sentimental reasons, my favorite Alfred Hitchcock movie is North by Northwest. And then my second favorite is Psycho. And my third favorite is Vertigo. Oh, look, I'm coming up with a trivial example just to keep our thoughts organized, but these could be three factions in society that have roughly equal size, and we're choosing between starting a war with somebody, trying to create peace with somebody, or asking a third party for help. I mean, the labels of the alternatives aren't that important right now, because we're not going to talk about sort of how to parameterize choices. We're just saying preferences over some alternatives. Alfred Hitchcock movies, war tribunals, it's all the same right now. Now suppose that we, the charter members of the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society, wanted to put out our definitive list, and we decide that the way that we're going to proceed to create a ranking, we want to make a ranking. And we decide that our rule is we will take every pair of movies, and this is all in the meticulously constructed bylaws of the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society, okay? Like, this is in the bylaws. This is like Rule 27, Part 2. Chewy was very thorough when he wrote the bylaws. So we decide that what we're going to do is we're going to use majority rule on every pair of alternatives. Some of you might, once I wrote down the preferences, some of you may have noticed something, but... So, we need to make three comparisons. Psycho versus Vertigo, Psycho versus North by Northwest, and Vertigo versus North by Northwest. All right? So suppose that the first vote of our esteemed society is Psycho versus Vertigo. Okay, well, you have Psycho ahead of Vertigo, Chewy has Vertigo ahead of Psycho, and I have Psycho ahead of Vertigo. So by virtue of a 2-1 majority rule, you and me versus Chewy, we have Psycho beats Vertigo. So Psycho is strictly preferred by our society to Vertigo. Vertigo versus North by Northwest. Well, you have Vertigo over North by Northwest, so does Chewy, but I have North by Northwest over Vertigo. So by virtue of a 2-1 vote, you and Chewy against me, Vertigo is strictly better for our society than North by Northwest. Finally, Psycho versus North by Northwest. Well, you have Psycho over North by Northwest. Chewy has North by Northwest over Psycho, as do I. So Chewy and I are now a 2-1 vote against you, and so we have North by Northwest over Psycho. So in other words, we go Psycho over Vertigo, Vertigo over North by Northwest, and North by Northwest over Psycho. Well, you don't need to draw the 3 dots to see that there's a cycle. We have cyclical preferences in our esteemed Greater Champaign Urbana Alfred Hitchcock Appreciation Society, despite the meticulously crafted bylaws that Chewy worked so hard on. Right? So even though each of us is perfectly rational, reflexive, complete, transitive, right? Heck, we even made it easy by having only strict preferences, right? We didn't even have any indifferences to work around. Everybody came in with an unambiguous and consistent set of preferences over these 3 movies. Nevertheless, our society is already on the ropes, right? So this, of course, no, not of course, maybe you haven't heard of this before, which is totally reasonable because you came to college to learn stuff like this. So this problem is referred to as Condorcet's paradox. It's named for the Marquis de Condorcet, who was, if he wasn't the first person to notice this, he was probably the first person to encode it this particular way. But he noticed that majority rule, which is something that we use all the time, was subject to problems, these cyclical problems. And he noticed this in the late 1700s. I mean, this has been around for a while. So there's a couple possibilities. One is, do we think that this profile of preferences that we came in, do we think that this is unreasonable? Do we think that this is something that could never happen in society? I don't. I think that things like this could happen all the time. This doesn't seem completely implausible to me. Because the reason I'm saying that is, if we had all had the same exact preferences, then there wouldn't have been any trouble. Majority rule would have gotten us a nice, consistent preference relation, right? It was something about this particular profile of preferences, this cleverly constructed profile of preferences, that the Marquis de Condorcet came up with. This cleverly constructed set of rankings, coupled with majority rule, created this interesting and memorable problem, right? This isn't a game theoretic model, but this is what a formal model is supposed to do. It is supposed to stick in your head, right? Now, chances are good you will never forget the majority rule is subject to cycling problems like this, because it's easy to remember. So the question is this always going to happen? Is it a problem with majority rule? Is it a problem with certain kinds of preferences? Is it a problem with the number of people or the number of alternatives? There's all sorts of different things that could change. And maybe any one thing that changed might be the saving grace that saved us from cyclical problems like these. Because think about this. These cyclical preferences are a violation of transitivity on a societal level. So every one of us could have a utility number. U of Psycho for you is 2, and U of Vertigo is 1, and U of North by Northwest is 0. And likewise for Chewy, and likewise for me. We all have preferences that are well behaved enough to be able to create a utility function that represents them. Right? So individual level utilities are not a problem in this world. Yet, societal level utilities are. Why? Because there is no utility function that could represent these preferences. We talked about that last week. Once you have an intransitivity, you can't come up with a numeric representation to simplify this. So, thinking about these as citizens voting on foreign policy alternatives, how could we ever give a country a utility function? People give countries, if you, in any of your other IR classes, if there was a formal model, if you learned the bargaining model of war, if you learned any of there's a cajillion papers in the last 40 years say, here's country X, and they've got a utility function. And here's country Y, and they've got a utility function. How? Now, I'm not going to have a definitive answer, and I think it's totally reasonable to give countries utility functions, but I want to show you a particular problem with that. So I'm framing this in terms of a methodological issue. I'm saying, because of this Condorcet paradox, maybe majority rule isn't something that can get us a society with a utility function. But it's also a deeply normative question. Can society land on anything consistent, or are we doomed to have sort of cycles among some top cycle? In order to answer these broader questions, we'll have to get away from this simple Condorcet paradox, wonderful example, and develop a more general framework. And so that's what we're going to do for the rest of this block. The first thing I want to talk about is the set of all rational preference relations. Okay? So suppose that there were 3 alternatives, X, Y, and Z. So capital X equals X, Y, Z. let's just think about for a second all of the different ways that you could rank these alternatives that would still be rational. And I'm just going to use a little tabular thing to keep this easy, but you can imagine putting squiggly arrows in whenever you need to. So it could be that you have x better than y better than z, or x, z, y, or y, x, z, or y, z, x, or z, x, y, or z, y, x. So in other words, there are 6 ways to have only strict preferences, right? So x is better than y is better than z. X is better than z is better than y. We haven't allowed for any indifferences yet. So there's also a world where you're indifferent between x and y, and you like both more than z. There's also a world where you like z better than x and y, which you're indifferent between. There's also a world where you like x and z, you're indifferent between them, but you like them both better than y. And there's also a world where you like y best, and then you're indifferent between x and z. There's also a world where you like y and z the same, and you like them both better than x. And finally, there's a world where you like x the best, and you're indifferent between y and z. So there's 6 ways to be indifferent between 2 of them, and then whether that indifference is above or below the odd alternative out. Finally, it could be that you're indifferent between all 3, x, y, z, altogether. So if you give me 3 alternatives, there are 13 different rational preference relations on them. Some of them are very strict, some of them are very indifferent, some of them are somewhere in the middle. So we're going to come into this model. Part of the framework is going to be a finite set of alternatives, which we're going to call x, just like before. And the idea here is that all that we know about a given person's preferences is that they're one of the possible rational preferences. So over this x equals xyz, I'm going to call that squiggly-R, and squiggly-R is the set of all rational preferences on the set of alternatives x. Okay? So I don't know which of these any given individual has. I just know that the given individual is rational. So, unlike last week, this time we're going to have a bunch of different individuals, okay? So we're going to have both capital X, which is a finite set of alternatives, with at least 3 alternatives. Otherwise, this is pretty boring. And we also have capital N, and that's our set of individuals, where I'm going to number them 1, ... little n. So there are n individuals in society. Those are the main primitives. And the idea here is we want to say that what the exogenous information for a society, the thing that a society has to take as given, the thing that a society responds to, is a profile of every individual's preferences. Okay, so the idea here is that society needs to read in every individual's preferences. Yours, mine, Chewy's, everybody's. So we're going to make a big ordered list. We're just going to make a tuple. And how many things are going to be in this? N, 1 for every person in society. All right? So I'm just going to call this person 1's weak preference ranking, person 2's weak preference ranking, person 3's, ... person N's. All right, so this is the input of our model. This is a list of everybody's preferences over the set of alternatives X. I'm going to call a big parenthetical list like this where the order matters. The idea is that the first entry is person 1's preferences, the second entry is person 2's, the last entry is the last person's entry, whatever, okay? So I'm going to refer to something like this as a preference profile. A preference profile. It's a profile of individual level preferences. This is a snapshot of society's preferences. That's in a reductionist sense. We're saying this preference profile gives you every individual's preferences over the set of alternatives X. And they could all be different. They could all be the same. They could all, whatever. All that we know is that every individual ranking is rational. We now have a set, not just of all possible preference rankings, we have a set of all possible combinations of preference rankings, okay? All possible versions of person 1 against all possible versions of person 2 against all possible versions of... This is a big set. This is a very big set. Especially, the set of alternatives might be big too, right? So this is just this is just the set of all possible rational preference profiles. It's way easier to think about this conceptually than symbolically. So the idea here is that this squiggly-Rn, the set of all possible rational preference profiles, the idea here is that that is going to be the domain of a function. Okay? So here's a blob, and here's some dots. And let me just call attention to a couple of dots. So for example, let's just say that it's Chewy, you, and me again, and we've got three alternatives, A, B, and C. Okay? So this top dot up here, that's the one where we all agree that A is better than C is better. A is better than B is better than C. So you have A, then B, then C. Chewy has A, then B, then C. I have A, then B, then C. That's one of the dots. There's another dot, and it's the dot where we're all indifferent, right? So you have A, B, C, I don't care. Chewy has A, B, C, I don't care. I have A, B, C, I don't care. Here's another dot where maybe you and Chewy agree that A and B are indifferent between A and B, and then C. And Chewy has A and B indifferent, and then C. And maybe I go C, and then A, and then B. So these dots, every dot is just a profile, a possible snapshot of everybody in society's preferences. So that's the input of a function. And you're like, what's the function? The idea here is that the function is going to be something that reads in everybody's individual level preferences and spits out a ranking that represents society. The definitive list of the Alfred Hitchcock movies, as stipulated by the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society, with 3 charter members. So in other words, it reads in individual societal preferences and it spits out a societal set of choices, or a set of rankings. So I'm going to refer to this F. I'm going to call this F. That's the function. And I'm going to call that a preference aggregation function. So it reads in individuals and it spits out some aggregation. I'm going to talk more about that in a moment, but let me just specify the codomain of our function first. What does it spit out is what I want to know. So it's a blob. So what are we going to ask of the output of societal preference aggregation functions? Well, we're going to ask it to be complete and reflexive. We're going to say, hey, for every pair of alternatives, society either has to like one more than the other more than the one, or both. It's complete, just like last week. So we're going to require that for every pair of alternatives, society doesn't say, I don't know. Society can be indifferent. Society can say, oh, well, A and B, we don't care. So I'm going to call the set of all complete rankings on X squiggly B. Okay? So it can spit out total indifference. It can spit out something cyclical, like we just saw in the example of the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society. It doesn't have to be transitive. It only has to be complete. And so there are dots. And just to call attention to that, maybe one of the dots is a well-behaved one. It's like A and then B and then C. And then another one of the dots is A is strictly better for society than B, B is strictly better for society than C, and C is strictly better for society than A. We're going to allow that. We're going to say a possible output for this. So we know that from majority rule, there exists a preference profile that makes that happen. That's Condorcet's paradox. So far we have a profile, a snapshot of individual level preferences, and we have a target of society can't say I don't know. Society has to make some comparisons. We haven't said anything about how those preferences get aggregated though. We've seen one example with majority rule. Let me show you what that looks like, because we're gonna be agnostic about what F is. There's too many Fs in the world. We don't know. There's so many ways to, if you just look at a bunch of different organizations, different ways of aggregating preferences, there are way too many for you to study all at once. So let me just introduce some of these examples that we can use whenever we need to call our attention to a particular one, but for the most part, we're gonna be agnostic about F. Let me repeat that. We're gonna study all sorts of Fs. All sorts of societal preference aggregation rules. It will be very natural for you, if you're anything like anybody else that learned this, the first few times you're just going to keep thinking, and it's majority rule, right? We don't know what F is. We don't know what F is. We don't know the bylaws. We don't know society's bylaws. So let me show you a couple of different versions. So let's just encode majority rule. So for simple majority rule, we'll say that for all arbitrarily chosen pair of alternatives, maybe call them X and Y, that live in X, we'll say X is strictly preferred by society, and I'll just drop the subscript and then just put a star there to say, hey, this is society's. So we'll say X is strictly better for society than Y, if and only if the number of people that have X strictly better than Y in their individual level preferences is more than little n over 2. So if over half of the people strictly prefer X to Y, then society will also strictly prefer X to Y. By completeness, if X isn't strictly better than Y, Y is at least as good as X. We're going to lean on that little toggling a couple of times today. But that's just one way to aggregate preferences. Suppose that there was, suppose that majority wasn't enough for you. Suppose you were in the Senate, or you were passing a constitutional amendment or something. Supermajority rule is required, right? So I could have chosen any threshold. N over 2 is only one threshold. Simple majority rule is a special case of what you might call quota rules, where the idea is that there have to be a certain proportion of people that strictly prefer X to Y, right? So, for example, if it was 3/4, then instead of N over 2, I just have 3/4 there. They don't all have to be quite this simple. So suppose that you're trying to pick your favorite football team. You're trying to figure out what college football team you think is the best. So every year when there's football, every week there's a ranking that gets put out by the Associated Press. There's another one by the coaches, blah, blah, blah. And the idea there is the following. Every voter in a given poll sends in a ranking of what they think are the 25 best teams in order. They rank Alabama 1, they rank Texas 2, they rank Georgia 3, whatever. And then what happens is, whoever gets ranked number 1 in the vote gets 25. And whoever gets ranked number 2 gets 24 points. And whoever gets ranked number 3 gets 23 points. All the way down, ... until the team that was ranked 25th gets 1 point. So everybody sends in their rankings, and every ranking leads to a bunch of points. And then you add all the points together and see who has the most sort of weighted votes, right? That's called a Borda Count, B-O-R-D-A. This is a common way to, especially if you have a bunch of alternatives. If you have to come up with the 25 best football teams, that's a ranking, right? You need a complete transitive and reflexive ranking there for all the teams. How do you make numbers like that? This Borda Count is a way that people do it. Just to show you they don't have to be reasonable, consider the rule, Rob is a dictator. So the idea there is that X is strictly preferred to Y, if and only if X is strictly better than Y for Rob, for any XY. So suppose that you went A and then B and then C, and Chewy went A and then B and then C, and I went C then B then A. We got to compare A and B. Well, you have A over B, Chewy has A over B, I have B over A, so B beats A for society because Rob's the dictator. What about B and C? Well, you go B over C, Chewy goes B over C, I go C over B, so C beats B because Rob's the dictator. You have A over B, Chewy has A over B, I have B over A. That means B beats A because Rob's the dictator. So in other words, under the preference aggregation rule that Rob is a dictator, society's final rankings are equivalent to my rankings. So we have a big giant blob on the left, and we have a big giant blob on the right, and we have all sorts of different functions that might live in the middle. What does that mean? Let me put that in words. There are many different combinations of preferences for all the individuals in a society. That's the big blob on the left, right? And there are many different choices. There are many different policies that society could make. That's the big blob on the right. And there are many ways to turn individual level preferences into societal policies. That's the function. It's a huge framework when you think about it. You might be saying to yourself, well, maybe we can whittle down the different inputs, right? Maybe we don't have to consider every possible pair of combinations for society. To which I would say, boy, it's a bit of an act of vanity to think that you're going to know in advance what society's preferences are going to look like. When you're choosing a preference aggregation rule, if you're not thinking about all possible contingencies in terms of people's preferences, there's a good chance that you'll wake up 200 years from now, and things are so different that the preference aggregation rule that you chose, when it worked for one subset of squiggly-Rn, it wasn't ready for the next subset of squiggly-Rn. But we have baked that assumption in. This institution has to be prepared for all possible contingencies, where a contingency is defined as a combination of individual preferences. Regardless, what we have is huge. It will be impossible for us to study it all without trying to choose some North Stars. So in the B block, we're going to talk about different criteria that one could choose to figure out what a good, let me get that higher, good social preference aggregation function would look like. So let's go to the B block. So we were just discussing how big the problem of preference aggregation is. There are many different combinations of preferences, even once we whittle down things just to rational preferences. There are many combinations of societal preferences. There are many different policies that society could choose, which is to say both the domain and the codomain of our function are very large. And there are many different functions that could link those two sets, right? So we have a very big problem. And the way that things proceeded for a while was people would take some F, some preference aggregation rule that they thought was interesting, majority rule, Borda Count, whatever, right? And they would say, boy, this seems to be a pretty good rule because it satisfies some criteria. And then somebody would say, oh, but here's another criterion that it doesn't satisfy, right? So majority rule is great for all sorts of different things, but the Marquis de Condorcet noticed that it has an unpleasant property of possible cycling. He noticed that in the 1700s, right? So the insight that Ken Arrow gave us, the great Ken Arrow, this is probably, if not one of the most important, perhaps the most important social scientist of the 20th century. His insight, and this was his dissertation. Can you imagine that? So his insight was to say, it doesn't make sense for us to try to do this F by F by F. We shouldn't do like, oh, Borda Count versus majority rule, battle royale. Instead, what we should do is we should write out some criteria for what we think constitute a good preference aggregation rule ought to satisfy, right? So that's the idea. The idea here isn't to study each of the different Fs one by one. That would take you forever. The goal here is to say, what are things that I would want any F to satisfy? What are the criteria? What are the axioms? And this is normative. What are the normative criteria that I would want any preference aggregation rule to satisfy? So I'm going to talk about 4 of those, all right? And these will be in increasing order of trickiness, all right? So the first should sound familiar to you. It's transitivity. We want society's preferences to be transitive. What do I mean by that? I mean the same thing as any in other preference ranking. So I want it to be the case that any time that X is at least as good as Y for society, and Y is at least as good as Z for society, I want to also know that X is at least as good as Z. Why? Well, there are technical and normative reasons. On the technical side, if we want to be able to equip a society with a utility function, if we want to be able to apply a utility function to anything more numerous than an individual, then we need the choices, we need the rankings that they generate to be transitive. We learned that last week. If you don't have transitivity, you can't represent it, right? The Greater Champaign Urbana Alfred Hitchcock Appreciation Society is on the ropes in terms of having a utility function because we found a profile that was cyclical, so there couldn't be a utility function, which means that, like, a lot of IR scholarship is out the door. There's also a normative justification. One of the nice thing about a society, one potentially nice thing about society is that it regulates a little bit. It offers a measure of consistency. It would not be easy for you to form expectations about what to expect next, and thus for you to make good choices. You might not be able to make that calculation about what to expect next if society's choices were cycling all over the place in a way that you didn't fully understand, right? So you might remember from last week's lecture, if there's a Sunday policy, a Monday policy, a Tuesday policy, and suppose that you don't know that chain, you don't know the timing, and your job is to choose when to go to college, when to buy a house, when to get a loan, whatever, right? It's hard for you to know how to make good choices as an individual in society if society's preferences are sort of wiggling all over the place in these chains. Then you don't know when you're going to get back to the status quo, right? That's what's going on there. So there's a normative justification, which that's way over my head, to be honest with you. But at minimum, I can say to you, if you want to be able to equip any society with a utility function, you need transitivity. The no dictators criterion. I'm going to tell you who is an Arovian dictator. So, an Arovian dictator is somebody. The adjective form of the last name Aro is Arovian. The Arovian dictator is somebody that if you chose any two random alternatives, x and y, just choose them arbitrarily. So for all x and y, choose any pair of alternatives. Any pair. Then x is strictly better for society than y, if and only if x is at least as good for person I as y. So in other words, the Arovian dictator is somebody who you choose any two alternatives. You choose any two. And we want to know how to compare them. The Arovian dictator gets exactly what they want every time. Which is to say, they are decisive for every pair of alternatives. So there are some factors where I think it's okay for a given individual to be decisive, right? So I want the color of my house to be whatever I want, right? That's an aspect of my life that I don't want other people's choices to matter. If I decide to have a white house or a pink house or a red house or a plaid house, no matter what, I think that my preferences ought to be what decides that outcome. So I should be decisive over some small set of alternatives, right? It's possible to think that. It's a somewhat controversial thing to say. The Arovian dictator has that level of power over everything. Not only do they have that much influence in terms of the color of their own walls, they also they get to tell me what color the walls of my house are. They get to be perfectly decisive over every pair of alternatives. All right? Nobody in history has ever had the kind of power that the Arovian dictator has. When you think about it. Julius Caesar didn't control all of Rome with that kind of power. Mansa Musa didn't control all of Mali with that kind of power. Catherine the Great didn't rule with that kind of power. The most powerful leaders in history. Everybody that's ever been somebody that you can play in Civ. They haven't had that kind of power. Nobody has ever had that kind of power. No human anyway. I think it's perfectly reasonable that we try to find a preference aggregation rule that satisfies that there isn't anybody with that kind of power. I think that there's any preference aggregation rule that failed to satisfy this criterion, I am perfectly comfortable saying that preference aggregation rule sucks. I hope that we can avoid dictatorship. We'll see. Foreshadowing. That was just a little bit of foreshadowing. I'm so sorry about my voice. I gotta record another lecture after this too. Serenity now. Serenity now. Criterion 3. Unanimity. This is another normative justification. So here's the idea. Suppose that there was a pair of alternatives that everybody in society decided that one was strictly better than the other. They all agreed. Just imagine a world. I know it's hard. Imagine a world where there was a pair of alternatives that everybody agreed on. Right? So in other words, imagine that we had some x and y such that x was at least as good for I as y for all I and n. Everybody has x strictly better than y. In that world, don't you think it's reasonable that we demand x is strictly better for society than y? Now look, this has nothing to do with what happens if there's one person that doesn't agree, right? We're only saying for the tiny subset, the tiny part of that domain where everybody agrees on something. That's highly unlikely that everybody would agree on something. It doesn't happen very often. You could offer, suppose that we polled everybody in the United States and say, hey, what do you think that we ought to do? Give everybody in society a slice of chocolate cake or start a nuclear war with Canada. Somebody would choose the latter. Somebody on a keto diet would say, Well, I don't like the idea of nuclear war, but carbs, man, carbs. It's hard to find that level of agreement on anything because some people, there's no accounting for that. But what we're saying with this criterion is in the highly unlikely contingency where there's a pair of alternatives that everybody agrees on, strictly, then society's got to follow those people. Now look, this has nothing to do with if there's one defector, two defectors, etc. We're only talking about unanimous profiles. You're either a unanimous profile on two alternatives or you're not. And if you're not, then this criterion has nothing to say. 4 is the hard one. And it's made for both substantive and technical reasons. It's called IIA, the independence of irrelevant alternatives. And the idea is the following. You don't want intensity of preferences to matter too much. Okay? We want only the ordinal rankings for any two alternatives to be the thing that matters. So it'll be easier to define IIA if I define a quick concept about how two profiles handle two alternatives. So consider one preference profile, and we'll just call this maybe like superscript 1, where individual 1 has a ranking, ... individual n has a ranking. And consider another world, we'll call that one preference ranking 2 world, okay? And again, everybody has a preference ranking. Maybe they're the same, maybe they're different, who knows, okay? All I'm saying is I'm going to be able to say something about, I'm going to define a relation between two preference profiles. I'm going to say that if I choose two alternatives, call them A and B, I'm going to say that profile 1 and profile 2 treat A and B the same, right? If, for everybody in society, A is at least as good in world 1 for I against B. So if A is at least as good for person I as B in world 1, if and only if A is at least as good as B for person I in world 2 under profile 2. So two profiles treat A and B the same if every individual's ranking of A and B, be it A ahead of B, B ahead of A, or indifferent, is the same. What we're trying to say is it doesn't matter if there's a whole lot of room in between them. It doesn't matter if they're all the way at the top or they're all the way at the bottom. All that we want to do is compare the ordinal comparisons, the ranking comparisons. The idea here is that you don't want intensity to matter. Okay? So for example, let me show you two profiles that treat two alternatives the same. So suppose that you, Chewy, and me are picking a movie. So you have A and then B and then C. And let's say that Chewy is indifferent between C and A, and then he's got B underneath them. And let's say that I'm indifferent between all three. Okay? So that's world 1. You go A, then B, then C. Chewy goes C, A, and then B, and I go A, B, C. I don't care. And here's another world. Let's say that you go A first, and then B, C, indifferent. And then Chewy goes A, and then C, and then B. And let's say that I'm indifferent between A and B, but I like them both better than C. In the second world, you go A, and then B, C. Chewy goes A, then C, then B. And I go A, B, then C. So these are very different preference profiles, right? However, notice that they treat A and B the same. In world 1, you had A strictly ahead of B. In world 2, you have A strictly ahead of B. In world 1, Chewy had A strictly ahead of B. In world 2, Chewy has A strictly ahead of B. In world 3, I was indifferent between A and B. And in world 2, I'm indifferent between A and B. So you're the same in both worlds in terms of AB. Chewy's the same in both worlds in terms of AB. I'm the same in both worlds in terms of AB. These two preference profiles treat A and B the same. They don't treat B and C the same. Why? Well, in world 1, you had B ahead of C, and in world 2, you're indifferent between the two. So you're not the same B-C comparison. So these two worlds don't treat B and C the same. Nor do they treat C and A the same, because I had to be indifferent. But they do treat A and B the same, despite being very different. Okay? So what's independence of irrelevant alternatives? It means that if two profiles treat A and B the same, then whatever society's preferences in terms of AB are in world 1 must be society's preferences in terms of AB in world 2. Okay? So if two profiles treat two alternatives the same, then society's preferences over those two alternatives also have to be the same. The idea here is that you don't want it to be the case that if there's a whole lot of things in between, then suddenly the ordinal comparison gets distorted. You don't want the intensity of preferences or some rough proxy for the intensity of preferences. Arrow's argument here is that we only want that ordinal information to be what matters. All right? So that's IIA. And also the concept of treating two things the same. We're going to use that quite a bit. So one good way to drive home IIA is to prove, or not to prove, but you're going to see an example on your problem set that the Borda Count, where sort of you're giving everything a ranking, that violates IIA. Why? Well, if I think Illinois has the best football team, if I want them to be high at the ranking, maybe I'll rank them first, and then whoever I think is the second best team, I'll rank them way lower or something. Why? Because that intensity of preferences kind of matters. We have now defined, there's too many F's in the world. There's too many social preference aggregation functions. There's too many ways for us to turn this massive domain of possible combinations of individual preferences into this massive set of societal preferences. There's way too many ways to do it. There are too many Borda Count, simple majority, quota rule, unanimity, Rob is the dictator. There's all sorts of them. There's too many of them. So instead we're going to say, hey, these are 4 criteria that it seems like we would like a rule to satisfy. Okay? Transitivity is important for normative reasons. We want there to be stability, and also for technical reasons. We want to be able to use a utility function to represent society. No dictators is important because we don't want to equip any individual with the sort of power that has never been seen on Earth before. Unanimity is important because, man, it just doesn't happen that often that everybody agrees about something, and if they do, it's probably good for society to go with that. And IIA is good because we don't want there to be volatility induced just because, like, what was your second favorite among your favorite set of alternatives beat your first favorite among your least favorite class of alternatives, right? That's what IIA is doing, is it's saying it shouldn't matter if one alternative is among your favorites and another alternative is among your least favorites. Where they are within the class of your favorites and your least favorites shouldn't matter. It's just that one of your favorites against one of your least favorites. That's all that should matter. So these all seem sensible. It would be great if we could find rules that satisfy them. And that will be our quest in the C block. So just to recap what's happened up to this point. We said social preference aggregation is hard. We saw that from the meeting of the Greater Champaign-Urbana Alfred Hitchcock Appreciation Society. And we said, well, we wonder if these problems of preference aggregation are something pervasive. And in order for us to get a sense of that, we've had to develop a big Arrovian framework. We've got a big input set, all the possible profiles where every individual society is implausibly rational. We've got a giant output set as every possible complete ranking that society could serve. And we've got this F that reads in individual level preferences and spits out society level preferences. And because the task is so big, we have come up with some criteria that we would like to see what rules satisfy them. All right? And here's the punchline. Theorem. Let me stop wiping. This is important. Here's the punchline. Arrow's theorem tells us that there does not exist a preference aggregation rule that simultaneously satisfies transitivity, no dictators, unanimity, and IIA. That sucks. Let me repeat that. There is no preference aggregation rule that can guarantee you that no matter what preference profile you feed it, it will satisfy all four of these really important seeming criteria. Put differently, you can't get everything good every time. There may exist preference profiles for which everything goes great, but there is no rule that can guarantee you that no matter what wacky combination of rational preferences you feed it, that there won't be something bad happening. How would you prove something like that? Well, here's a different way of stating the same thing. If a preference aggregation rule satisfies transitivity, unanimity, and IIA, if it satisfies three of those things, then there must exist a dictator. What? So we're going to prove Arrow's theorem. This proof of Arrow's theorem is not important for your problem set. You can stop the video right now if you want to. You can jump ahead to the provocative thought at the end. You don't have to prove Arrow's theorem with me. However, it's important that you see it. Now you know. And you've seen a clear statement of it. You know what the criteria are. You know what the framework is. You know what the theorem states. Right? So the proof is just why it's true, which I think is very important and edifying. But if that's too much for you right now, I get it. Right? You can just stop. You can just pause. Arrow's theorem has many proofs. There are many different kinds of proof. There are many different ways that you could prove that this column of T's tautology is true. Somewhat nostalgically for me, I'm going to use a method that was devised by my own teacher. I've been very lucky to have good teachers. Unfortunately, none of it rubbed off. This is by my teacher. His name is Mark Fay. And what I love about this proof is that you really see just how unanimity, IIA, and transitivity combine to create a dictator, right? So all that we know is that there's a preference aggregation rule that satisfies those three wonderful criteria. And we're only going to lean on that, but we're going to lean on them very often and in interesting combinations so that you can clearly see the emergence of this dictator. I want to call particular attention to a kind of proof that I'm not going to show you today, but that is by one of my favorite social scientists. Her name is Graciela Chicholinsky. She's somebody that she had a math PhD, and then she was like, oh yeah, that's not enough. So then she did an econ PhD, and so she proved Arrow's theorem using mathematical techniques that nobody could understand. Just insane. And actually she showed that Arrow's theorem is exactly the same, mathematically, as there exists a set of prices that set supply equal to demand. And you're like, how could those be related? And you're like, if you go deep enough into the mathematical DNA of these things, the problem of markets is exactly the same as the problem of social choice. How did she do that? So what I mean to say is, when you choose a proof of a theorem to show to a student, you can choose the deepest one that shows you the deepest relationships between the theorem and other things. Or as in this example, you can choose a super simple one that's almost folksy, and you're like, oh, I see this is all happening, and oh, there's a dictator. That's what happens in this proof. And you're like, we're going to identify a suspect. We're going to identify a suspect to be the dictator. We're going to say, I think that this person smells like a dictator. And then we're going to confirm that they are. So this is the law and order of Arrow's theorem proofs. I need to get the sound. I don't know the name. I mean, obviously I can't do that. I think that's probably copyrighted. But if I Google... So here's what we're going to do. We're going to... The proof is in 7 steps. And you're like, none of them is complicated. None of these steps is complicated. The whole charm of this proof is that it kind of starts off, find the candidate dictator. I'm going to try to say candidate dictator until the end of the proof, because our dictator should be innocent until proven guilty, but I might just say dictator sometimes, and I'm sorry about that. So what we're going to do is we're just going to arbitrarily choose two alternatives, A and B. And we're going to arbitrarily have them at the top of everybody's ranking. Because by IIA, it doesn't matter if they're at the top, they're at the bottom, it doesn't matter. As all we care about are the A-B comparisons to start. And we're going to identify our candidate dictator just by looking at the A-B comparisons in a particular way. And then what we have to do is show that I promised you, candidate dictator's apparent decisiveness over A and B. If we take transitivity, unanimity, and IIA seriously, those will have downstream consequences about other alternatives. Because remember, to be a dictator, you have to be decisive over every pair of alternatives, not just A and B. So let me show you what I mean. So let's just begin from a world, and I'm going to do this with tables, where P1, P2, ... Pn, okay? So suppose there's a world where everybody in society has A over B and then everything else. Sorry, I'm not doing this off the top of my head in case you were worried. Right, that would be a little bit much. Also, I don't want to get my own teacher's stuff wrong. So imagine a world where everybody agrees that A is better than B and then everything else. All right? By unanimity, we know that in this world, A has got to be strictly better than B for society. All right? Now consider another world that's P1, P2, ... person, every person. And imagine that in that world, everybody has B over A and then everything else. B over A and then everything else, ... B over A and then everything else. And we know in this world by unanimity that B has got to be strictly better for society than A. And the idea here is that we're gonna slowly morph the left world into the right world. We're going to do that by changing one person at a time. And we're going to see if the world changes, because we know F. We know that there's an F. We know that there's a social preference aggregation rule, and we know that it satisfies unanimity, transitivity, and IIA. We don't know anything else about it. So we're just going to toggle. So suppose we took person 1, and we switched their preference from A to B and then everything else to B to A and then everything else. And then we check to see if the world changes. Does society's preference change? If so, then stop. If not, and by society's preferences, I mean, is it still the case that A is strictly better than B for society? So right now in this world, we have person 1 thinks B is better than A, and everybody else thinks A is better than B. It could be that we switch, but it need not be. A switch, what would a switch be? A switch would be B is at least as good for society as A. I'm not saying we have to switch from A better than B to B better than A. We're just switching potentially even to a societal indifference. So if person 1 switching changes society, then stop. If not, change person 2. Switch them from A to B to A, and then everything else. And look, does society change? If so, stop. If not, change person 3. ... Until there comes a person who could be the last person, could be the first person, could be the 50th person out of 100, could be anything in between. We don't know who the person is, right? But we know there has to be one because we eventually get to the unanimity B over A, right? Eventually, this enterprise isn't completely hopeless. That unanimity is really saving us, because otherwise it could be just keep switching. And it might be that just we don't listen to unanimity B over A, but we've assumed that we must. So eventually we get the two profiles that are, okay? And this is going to be really important. So the definition of our candidate dictator, and I'm going to call the candidate dictator person I star. All right, so the candidate dictator is the person who is defined as the following thing is true. In the world where everybody to the left of them has B over A, everybody to their left has B over A, and person I star has A over B, and everybody to the right of them has A over B. Okay, so this was right before we made our last switch to identify the candidate dictator, right? So we changed person 1, we changed person 2, we changed person 3. By definition, Person I star is the person for whom this profile means A is strictly better for society than B. Call this profile 1. I'm going to call that profile 1. In profile 1, B is better than A for everybody left of the candidate dictator. The candidate dictator has A over B, and everybody to the right of the candidate dictator has A over B. That's profile 1. Profile 2, everybody to the left of the dictator, candidate dictator, everybody to the left of the candidate dictator has B over A. The candidate dictator, person I star, has B over A. And everybody to the right of the candidate dictator has A over B. And in this world, B is at least as good for society as A. Call that profile 2. And you're like, how do we know this? We're saying I started from everybody agreed that A was better than B. And that was, for society, A was strictly better than B by unanimity. And then we had another world where everybody agreed that B was better than A. And by unanimity, in that world, B was strictly better than A for society. And then we had this algorithm where change person 1, was there a change? No, then change person 2. Was there a change? No, then change person 3. ... Person I star was the person that it changed. So for example, if we were doing majority rule, I star would be like the 50th plus 1, they would be like the median voter, right? They would be the person in the middle. Person I star might be the very last person. Person N might be I star, we don't know. We don't know. All that we know is these two things are true. We know that in profile 1, A is strictly better than B for society. And in profile 2, B is at least as good as A for society, by definition of I star. If you understand that, the rest of the proof is just basically just checking things. All right? We have to check 6 things. Now look, we chose A and B. We fixed them. Those are 2 alternatives that Psycho and Vertigo are what we used. We used those 2 alternatives to define person I star. A Nerovian dictator is somebody that isn't just decisive A and B, B and A. And here, they're not decisive because it very much depended on everybody else's preferences. In order to be decisive, it has to not matter what everybody else does. All that we know right now is in worlds where the people left of the candidate dictator are B over A, the candidate dictator is A over B, and the people to the right of the candidate dictator are A over B, that's A over B. And we also know that in the particular profile, where everybody to the left of the candidate dictator is B over A, the candidate dictator is B over A, and everybody to the right of the candidate dictator is A over B, then it has to be the case that B is at least as good as A for society. That's all that we know so far. There's no decisiveness yet, right? All this is they're like, what, me? I don't even know what you're talking about. All I knew was I changed my mind. That means the society changed their mind, but I don't know. I'm not a dictator. Don't look at me. I'm just some dude. I'm just some dude in a red t-shirt with no voice left. I'm not a dictator. We're going to see. All right. The rest of the proof is about cleverly constructed profiles. There's going to be a lot of clever construction. You might not believe me. There's going to be moments where you're like, this seems a little bit tricky. And not tricky in like a hard way, like just tricky in a tricky way. But just trust me. Step 2. So step 1 was to identify I star. We have identified a candidate dictator. This is the suspect. Step 2. Now we're going to think about a third alternative, an arbitrarily chosen third alternative. So you choose any other alternative. Call it C. And I'm going to now show you that because of what we know so far, person I star is decisive for B over any other third alternative C. To do that, suppose the left people all go B, C, A, the people left of the candidate dictator. They all have preferences that go B is strictly better than C is strictly better than A. And suppose the candidate dictator has preferences A, then B, then C. And suppose everybody to the right of the candidate dictator has A, then B, then C. Notice, this profile, which I'm going to call profile 3, everybody in this profile treats A and B the same as they did in profile 2, which is to say, it's BA to the left, AB for the candidate dictator, and AB for everybody to the right. So by independence of irrelevant alternatives, we know that in this world, there has to be A is strictly better for society than B, because it treats this just the same way as what we knew from profile 1. That's what IIA is. What IIA does is it says, all right, if that's how you treated A and B that time, that's how you have to treat it this time. Note also that everybody in this profile that we wrote down has B over C. The people on the left do, the candidate dictator does, and the people on the right do. Okay? So by unanimity, we have to have B over C. Transitivity then gives us that A is better for society strictly than C. So in profile 3, we know a lot. We know that A is strictly better than B, we know that B is strictly better than C, and we know that A is strictly better than C. But now, suppose that we didn't know anything about the people on the left and the people on the right in terms of how they compared B and C. Suppose that we're completely agnostic about everybody and how on the left of how they do B and C and on the right B and C. Let me show you what I mean. So consider a class of profiles that goes like this. The people on the left, we don't know how they feel about B versus C. And they could all be heterogeneous on that. Some of them might have B over C, some of them might have C over B, some of them might be indifferent. We don't know. But regardless, the only thing that we know about the people on the left is that they all have B over A and C over A. We don't know how they feel about B versus C. The candidate dictator, suppose that they go B and then A and then C. And everybody on the right, suppose that we know that they like A better than B and better than C, but we don't know how they feel about B versus C. Suppose we're agnostic, we know nothing about how they feel about B versus C. So everybody on the right could be, and they don't know how to be the same, they can be heterogeneous. Some of them might have B over C, some of them might have C over B, and some of them might be indifferent between the two. All that we know about the people on the left is they have B over A and C over A. And all we know about the people on the right is they have A over B and A over C. And all that we know about the candidate dictator is they have B and then A and then C. Notice that this is the same as number 2. This is the same as profile 2 in terms of the BA comparisons. Everybody on the left has B over A. The candidate dictator has B over A. And everybody to the right has A over B. So we know that we must have B is at least as good for society as A, because that's what we got out of profile 2. Let's call this profile 4, by the way. Note also that this profile treats C and A the same as profile 3 did. Everybody to the left has C over A, the candidate dictator has A over C, and everybody to the right has A over C. And we knew in that world that A was strictly better than C, and so that must also be true here. So A is strictly better for society than C. Well, given transitivity then, we know that B has got to be strictly better for society than C. But look, we just said, I don't know anything about the people on the left and how they compare B and C, and I don't know anything about the people on the right and how they compare B and C, but I know, regardless, that B is strictly better than C. That's weird, right? You might need to rewind. But that's just true. That's true. That's what we just showed, that even though we don't give a crap about how the people on the left compare B and C, and they might all be different. Well, they can't all be different. There's only 3 ways to be, right? But there might be a lot of variety. And the same for the people on the right. The only thing that we know is that the candidate dictator has B over C, and lo and behold, so too does society. And that was for an arbitrarily chosen third alternative. A and B we chose to start, and we identified person I star using A and B. But this third alternative, there was no way that we knew that the third alternative was going to be something that B was the candidate dictator is decisive for B over C. That's kind of crazy. So now anytime, no matter what, anytime moving forward that you see that the candidate dictator has B over C, you know that society does too. And what we're going to show is that's going to happen for every other combination. So that's profile 4. So that was step 2. Step 2, we just showed that the candidate dictator is decisive for B over any third alternative C. Now we're going to show that the candidate dictator is also decisive for A over any third alternative C. To do so, we construct another profile. Call this one profile 5. And the idea here is that everybody on the left, we don't know how they feel about A and C, but we do know that they like A better than B and C better than B. But we're agnostic about their A-C comparisons. Anytime I want to show that the candidate dictator is decisive between a pair of alternatives, I have to be agnostic about what everybody else is doing there. Suppose the candidate dictator goes A, then B, then C. And suppose that everybody to the right of the candidate dictator goes, we don't know how they feel about A and C, but we know that they like both of them better than B. Well, look, unanimity gives us something. The people on the left have A over B, the candidate dictator has A over B, and the people on the right have A over B. So we need A strictly better than B for society by unanimity. We use all three of we're using IIA all the time. We're using transitivity all the time. We're using unanimity all the time. You really see that these three things are working together in tandem to create a dictator. Right? You're just weaving together these three. It's just three. It's three super simple axioms. Until next thing you know, you go, holy there's a dictator. But note also, the candidate dictator, we just found out that they're decisive for B over C. Right? So in this profile, look, everybody has C over B except for the candidate dictator, who has B over C. But that's one of the things that we covered in the last step. We don't, this is one possibility. This was possible. So because the candidate dictator is decisive for B over C, we have B is strictly better for society than C. That was step 2. Transitivity then gives us that A is strictly better for society than C. Now look, we were agnostic about A and C. We don't know how the people on the left are doing it. Some of them might have A over C, some of them might have C over A, some of them might be indifferent. We don't know. Same with the people on the right. We don't know. Nevertheless, we just found out that no matter what, if you want consistency, which is a pretty big if, but if you want consistency, then the candidate dictator is decisive for A over C. So that's what we learned from the class of profiles from number 5. Step 4. Now we're going to show that the candidate dictator is decisive for that third alternative C, whatever it is, arbitrarily chosen third alternative. The candidate dictator is decisive for it over A and B as well. So we're going to do A first. So consider the following profile. We will call this profile 6. Having fun yet? So suppose everybody on the left of the dictator, candidate dictator, has B and then C and then A. Suppose the candidate dictator has C and then A and then B. And suppose everybody to the right of the candidate dictator has C and then A and then B. Well, we have BA to the left of the dictator, candidate dictator, A strictly better than B for the candidate dictator, and A strictly better than B for everybody to the right. Well, that means from the very first profile that A is strictly better than B for society, by definition. Note also from unanimity, everybody has C over A in this profile, right? So the people on the left have C over A, the candidate dictator has C over A, and everybody on the right has C over A. So by unanimity, we also have C is strictly better for society than A. Now use transitivity, and we infer that C is strictly better than B for society. And that's for this particular profile. This is a very particular profile. There's no agnosticism here, right? There's no slashes. We know everybody, but we're going to use this now. We're going to use this. Okay, so that's profile 6. Now consider the following class of profiles. Call it 7. You're going to have to go over this a few times. Okay. This is my second time doing this proof today, thanks to the power of my battery. And I know it much better the second time than I knew it the first time. And I've taught this a couple of times. This is hard. But I really want you to see how these assumptions are working together. These axioms are working together. So consider the following format. To the left of the candidate dictator, suppose that they go B, and the only thing that we know about them is that like B more than A and B more than C. We're agnostic about how they compare A and C. Suppose that the candidate dictator has C and then B and then A. And suppose that the people to the right of the candidate dictator have A and C. We're agnostic about how they feel about A and C, but they like both of them better than B. Well, in terms of the A-B comparisons, this is the same as profile 2. It's B over A for everybody to the left of the candidate dictator. It's B over A for the candidate dictator. And it's A over B for everybody else. Well, by definition, this is how we define the candidate dictator. That means that B is at least as good for society as A. Note also that this looks exactly like profile 6 in terms of the C-B comparisons, right? So we have B over C for everybody to the left, C over B for the candidate dictator, and C over B for everybody to the right. That's exactly the same as in profile 6. So we have to have by IIA because this is the same in terms of C-B comparisons as profile 6. So we need C is strictly better for society than B. Well, by transitivity, C strictly better than B is weakly better than A. We know C is strictly better for society than A. But look, we were agnostic about everybody else. The only thing that we know in terms of CA comparisons in this profile is that the candidate dictator has C over A. And that's what society ended up doing. So the candidate dictator is decisive for C over A. That was step 4. Step 5. Now we're going to show that the candidate dictator is decisive for any third alternative C over B. To do so, consider the following profile, which I will call 8. Everybody to the left of the candidate dictator has A first, and then we're agnostic about their BC comparisons. The candidate dictator has C and then A and then B. And everybody to the right of the candidate dictator has A first, and then we're agnostic about their BC comparisons. We have some unanimity to work with. We have A over B for everybody in society. So we know that A is strictly better than B for society. And we know that the candidate dictator is decisive for C over A. That was the last step. And here the candidate dictator has C over A, which means the society has to have C over A as well. So C is strictly better than A by IIA in this decisiveness thing. Well, now we have C is strictly better than A is strictly better than B. We can infer that C is strictly better than B. We're agnostic about all those BC comparisons, but for everybody else in society. The candidate dictator is also decisive for any third C over B. So what have we shown so far? We used two particular alternatives, A and B, and we used them to identify a suspect, person I star. Since then, we have shown that that person is decisive for A over any third C, B over any third C over A, and any third C over B. That's what we know so far. All right? We still haven't figured out if the candidate dictator has any decisiveness on A and B. Remember, we used very particular A-B comparisons to define the dictator. Candidate dictator. Now we're going to remedy that. We're going to show that the candidate dictator is decisive for A over B and B over A, which are what we used to define them in the first place. So suppose, consider the following preference profile, which I will call 9. Having fun yet? I assure you, the other proofs of Arrow's theorem are not fun. I mean, some of them are really fun. The aforementioned Chichilinsky proof is amazing. Consider the following profile. Everybody to the left of the candidate dictator, all that we know, we don't know anything about them. We're agnostic about their A-B comparisons. The candidate dictator, let's give them A and then C and then B. And everybody to the right of the candidate dictator, let's just say we're agnostic about their A-B comparisons. Well, the candidate dictator is decisive for A over C and is decisive for C over B. So society has A over C and C over B, and society's got to be transitive, which means A has got to be better than B. So the candidate dictator is decisive for A over B. Just switch the A and the B in their ranking, have them go BCA instead of ACB, and you get the same logic, they're decisive for B over A. So now we know the candidate dictator is decisive for A over B, B over A over any third alternative C, B over any third alternative C, any third alternative C over A, and any third alternative over B. We haven't quite yet finished yet because we haven't. If you arbitrarily chose two alternatives for the candidate dictator to be decisive over, there is no guarantee that one of them will be A or B. Right? So right now we need at least one of the things that you happen to choose to be A or B. That's what we know about so far. We need an arbitrary X and Y, arbitrary alternatives. All right? So that's our final step. So let's just choose arbitrary X and Y in X. Keep A and B fixed. Suppose everybody to the left of the candidate dictator, we don't know how they compare X and Y. The candidate dictator, give them the following preferences. X is strictly better than A, is strictly better than B, is strictly better than Y. And everybody to the right of the candidate dictator, say, I don't know how they feel about X versus Y. Well, in this profile, any third alternative is going to happen twice, right? So any third alternative, X over A, because the candidate dictator is decisive for any third alternative over A, that means we have X is strictly better than A for society. Because the candidate dictator is decisive for A over B, we have A is strictly better than B for society. Because the candidate dictator is decisive for B over any third alternative, we have B is strictly better than Y for society. Therefore, we have X by transitivity invoked twice. We have X is strictly better for society than Y. The same would have gone in reverse if it had been YABX instead of XABY. And we've been completely agnostic about alternatives X and Y. So in other words, for any arbitrarily chosen pair, including the pair that doesn't include A or B, we're good. The idea here is that you might be thinking, hey, what if the A and B were outside? What if it was like A, B, and then XY? What if XY were at the bottom, right? Well, the idea here is that the XY comparison for the candidate dictator would be the same either way. It doesn't matter. We just happen to choose one where we could use what we knew, but no matter what, the thing that matters here is the candidate dictator has X ahead of Y, and nobody else, we don't know how anybody else compares X and Y. So even though this seems like a cheap shot, this is totally reasonable because anytime the candidate dictator has X ahead of Y, it'll be the same, whether there's independent ones or not. So that's where IIA is giving us our final little flourish. So I no longer have to call this person a candidate dictator. They are decisive for every pair of alternatives that you could choose. We're done with the proof. So I've pulled off of my bookshelf one of my favorite books. This is advanced. Don't buy this book. This is a book that I love to read before I teach stuff like this. So David Austin Smith and the late Jeff Banks, some of the finest teachers of this stuff that there ever were, and it's humbling to read their stuff because they're just such good teachers. And I want to read what they write about Arrow's theorem. It is difficult to overstate the importance and subtlety of Arrow's theorem. Mathematically, the result is straightforward, requiring little more than a rudimentary understanding of set theory to understand the argument. Conceptually, the result is far-reaching. When there are at least three alternatives, every method of aggregating individual preferences into some kind of social preference must violate at least one of the conditions of unrestricted domain. It has to cover all of the rational preference combinations, transitivity, unanimity, non-dictatorship, and independence of irrelevant alternatives. Thus, the choice of any particular aggregation rule necessarily involves trading off at least one of the conditions against the remainder. You can't have all good things at once. This is an important point. While in some particular instances, certain classes of preference profiles may well not be empirically relevant. There might be some wacky preference profiles out there, right? Insisting on a general domain restriction a priori is typically hard to justify. Like, you don't know what's coming. This is largely because the normative force of such restrictions must rely on the substantive interpretation of the alternatives under consideration. So in other words, if you want the consistency that we've asked of individuals that are rational, and you want to achieve that consistency in a minimally appealing way, then you must invest power into an individual. Right? This is sort of a subtle point. The only way that you can get the sort of consistency that you would ask of an individual while satisfying certain normative criteria is to invest power into the hands of one person. Now, transitivity might be asking too much. Maybe the individuals have to be transitive, but society doesn't. There's no reason to say that society must be transitive. So you can weaken transitivity. You can say, okay, I need a consistency requirement, but maybe not one quite so strong. For example, you might only want the strict preferences to be transitive, so that you don't have a cup of coffee problem in society. And if you weaken transitivity to that, if you say, I don't need weak preferences to be transitive, but I do need strict preferences to be transitive. If you do that, and we leaned on weak preferences being transitive a couple of times in that proof. So if you ask for that, if you reduce the transitivity requirement, if you say, okay, society doesn't have to be quite as consistent as individuals, then what you wind up doing is creating a small but larger than a dictatorship, and powerful but less powerful than a Rovian dictatorship group that in the social choice literature is referred to as an oligarchy. So, if you want full-on transitivity, if you want full-on rationality, you must invest power into the hands of an individual. If you're willing to weaken that requirement, then you must still invest power, but you get to invest less power into more people, which is normatively appealing. And in fact, if you weaken transitivity as far as it will go to the weakest requirement, which is called acyclicity, and we're not going to talk about any of this, I'm just saying this because it's interesting, then you can invest even less power into an even larger group called a collegium, and we refer to that as collegial rule. Now, neither an oligarchy nor a collegium is normatively appealing either, but I think most people would say that they are better than an Eurovian dictator. So, this might just be about how much consistency we're willing to ask out of society. However, these weaker requirements still wouldn't allow you to define a utility function, right? If we want to have America has a utility function, Canada has a utility function, Nigeria has a utility function, we need transitivity for that. We just said that the last lecture. So as a problem of method, rather than a problem of normative appeal, we IR scholars have to say, nope, Arrow's theorem is where I begin and end my argument, because if you don't have transitivity, then I don't have a utility function. So man the state in war is a waste of my time. I can't model countries then. I can only model individuals. So why did I do this? We've been awfully technical the first 2 weeks of this class. We've been very technical the first 2 weeks, and some of you may be wondering, why the heck am I doing this? And it's a good question. And I don't have a firm answer. But I did this because I think it's a memorable way to say to you, well, we're gonna sometimes have countries that have utility functions. We're gonna say, suppose that there's a country called the United States, and that it has a utility that maps alternatives to real numbers. It reads in alternatives and it spits out happiness numbers. It doesn't have to be a country. It could be a group, a kin group, an organization, a firm. Regardless, how do we give them utility functions? How do we do strategic international relations with them? It's hard. I did this also because I wanted to show you. I know you've been working hard the last 2 weeks. I know this is a foreign language to you, for many of you. I know it's been a struggle, and that your problem sets have probably involved some humiliation and some embarrassment. And I'm sorry about that. That's not my goal. But in 3 weeks' time, you've learned enough. Sets, functions, logic, rationality, to be able to, if not prove, and not even fully understand, but at least begin to understand one of the greatest things that ever happened in terms of the social sciences. This won a Nobel Prize. This started a literature that nobody knew was there. This launched a bunch of careers. later versions of other important results rely on Arrow's theorem, and you understand it. Isn't that weird? And I'm not saying that you get it all the way, and I know that you don't feel like you get it all the way, and I probably don't either. But you get it. You see it. You can begin to see it. 3 weeks in. And look, international relations is a rich area of research, a very important area of research, not just because we try to solve important problems, not just because we try to tap into important dynamics that happen at the international scale, not just because we care about the science of patterns of strategic interdependence at the international scale. It's a rich class of problems also just because it's an interesting set of puzzles to think about. And I don't mean any disrespect to anybody that works in international relations, which includes me. But I can't think of anything in IR that is such a lightning strike, such an epiphany, such a magical moment as the first time you learned this awful truism of Arrow's theorem. So I'd like to conclude with a provocative thought. One recurring theme in the social sciences and in international relations is that not all good things go together all the time. Sometimes good things go together. Sometimes you might get a preference profile that's well behaved enough that any social preference aggregation function will do a good job. But how to design an institution that can be robust to other possibilities is difficult. Not all good things go together all the time. Today we talked about good things going together in the context of presumably a domestic institution. A bunch of individuals are voting, and you could imagine this working at the national level. There could be intermediate levels too, state government, your school board, whatever. But there's also a nagging instinct that not all good things go together at the international scale too. Anybody that studies international relations has, no matter how scientific they may appear to try to be, and some of them are super scientific, they got pocket protectors and everything, they use calculators, it's very scientific. But most people that work in this field, and most people that study it as an undergraduate, are interested in it not just for its rich substantive interest, but also for normative reasons. We want to know how to make fewer wars. We want to know how to spread peace. We want to know how to spread prosperity. We want to make economic growth. Some people go further and ask, what is fairness? And I've been thinking about this for a while, a couple months, maybe a year or two. What are the axioms for international systems? So, in the context of an individual society, individual-driven society, it's easy to see why unanimity is a good thing, and why no dictatorship is a good thing, and even why transitivity is a good thing. Until the aliens come, we don't need a global utility function. Until the aliens come, we don't need transitivity for Earth. This is provocative. Nevertheless, the normative justifications for such an analysis are very important. You're not going to have a firm answer right now. Maybe you are, because it's also obvious to you, but what isn't obvious to me is, what are the things that we want to make happen at the international scale? How would we know a successful global preference aggregation function when we saw it? What would be the inputs? Would it be states' preferences, which we know are problematic? Would it be individual preferences? Would it be something intermediate? What would this look like for countries? And you're going to work on that a little bit in your problem set. But what are the axioms? What would good look like? What do we want our global society to look like? And how would you encode it? And would that be the first time that all good things get to go together? I doubt it. Thanks for watching.